Good afternoon, dear colleagues and guests. Today is the 22nd of January, 3 p.m. Moscow time. Let me declare open a session of the Dissertation Council for the defense of thesis by Konopelko Dmitry Leonidovich for the degree of Doctor of Geological and Mineralogical Sciences, Scientific Specialty 250001, General and Regional Geology, on the theme Paleozoic, granitoid, magmatism of Western Tien Shan. The order, St. Petersburg University, of the 16th October 2020, number 9305/1, me, Kudale Andrei Konstantinovich, Doctor of Geological and Mineralogical Sciences, Professor of the Department of Regional Geology, St. Petersburg University, was appointed Chairman of this Dissertation Council. Other members of the Dissertation Council were appointed with the same order, and let me introduce them to you. Arzamastsev Andrei Alexandrovich, Doctor of Geological and Mineralogical Sciences, Professor, the Department of Petrography of St. Petersburg University. Zaitsev Anatoly Nikolaevich, Doctor of Geological and Mineralogical Sciences of the Mineralogy Department of St. Petersburg University. Kozakov Ivan Konstantinovich, Doctor of Geological and Mineralogical Sciences, Principal Researcher, Federal State Budgetary Scientific Institution, Institute for Geology and Geochronology of the Precambrian period, the Russian Academy of Sciences. Kotov Alexander Borisovich, Correspondent Member of the Russian Academy of Sciences, Doctor of Geological and Mineralogical Sciences, Professor, Chief Researcher, Head of the Isotope Geology Laboratory of the Federal State Budgetary Institution, Institute of Geology and Geochronology. And Larin Anatoly Mikhailovich, Doctor of Geological and Mineralogical Sciences, Chief Researcher at the Federal State Budgetary Institution, the Institute of Geology and Geochronology of Precambrian period. In the remote access mode, we have Buslov Mikhail Mikhailovich, Doctor of Geological and Mineralogical Sciences, Professor, Head of the Laboratory of Geodynamics and Magmatism of Sobolev Institute of Geology and Mineralogy of Siberian branch of the Russian Academy of Sciences. Mikhail Mikhailovich, can you see and hear us? Yes, I can see and hear very well, thank you. Sobol Edward, Doctor of Geological and Mineralogical Sciences, Professor of the University of Potsdam, Germany. Edward, can you hear us? Please say yes. If you can.
Yes, I can.
Да, мне слышно. The degree applicant is also present, Konopelko Dmitry Leonidovich. Also, the scientific advisor of the applicant, Biske Georgy Sergeyevich, Doctor of Geological and Mineralogical Sciences, Professor of the Department of Sedimentary Geology at St. Petersburg University. To improve the quality of communication, dear colleagues working in the remote access mode, please switch off your microphones, but please remember to turn them on when you are given the floor or when you want to ask questions. Let me also inform you that our session is being recorded and broadcast live at St. Petersburg University website. The speeches are being simultaneously translated from Russian into English or from English into Russian. During the live broadcast of this session, an email is displayed. To that, all the attendees, all the listeners, may send their opinions and questions to the applicant online regarding his thesis and the current scientific discussion of his speech. These questions shall be forwarded to me by our technical support department, and I shall present them during our discussion. Questions should be related strictly to the applicant's speech and the content of his thesis, and it's necessary to indicate the full name, position, and place of employment of the author of the question. Questions that are not related to the scientific discussion of the thesis, the text and assessment of the thesis itself should not be presented. According to the order of awarding at St. Petersburg University degree of candidate and Doctor of Sciences approved by the local regulations of St. Petersburg University, hereinafter referred to as the Order, a session of the Dissertation Council shall be considered competent if at least 2/3 of the appointed members of the Council are present, but not less than 4 persons. Our Council consists of 8 persons. All 8 are present. Yeah, everybody's here, including 2 Council members in remote access mode. Audio-visual contact has been established with all the Council members and the applicants, so we have the quorum. Let me set forth the following procedure of today's session. The approximate duration, approximately 2 hours. First, the chairman summary report on documents submitted by the applicant and their compliance with the regulations, and answers to possible questions. Approximately 5 minutes. Applicant summary report outlining the key points of his research. Approximately 20 minutes. Questions to the applicant strictly on his report. No more than 2 minutes per each question. Answers of the applicant. 15 minutes for all the answers. Speeches of all the council members in turn with their assessment of the thesis and the applicant's speech with summaries of their positions, questions and suggestions to the applicant, approximately 10 minutes for each speaker. Speech of the chairman with his assessment of the thesis, also approximately 10 minutes. Answers of the degree applicant to questions and comments of the council members. Open discussion. Attendees may speak summaries of questions and specific suggestions to the applicant strictly on the theme of his study, no more than 2 minutes for each speaker. At that, all the speakers are kindly requested to register themselves in the registration sheet and introduce themselves fully before speaking. Next, the chairman shall present questions to the applicant sent during the scientific discussion and his report as the session was being broadcast online, and answers of the applicant no more than 2 minutes per each question. Speech of the scientific advisor no more than 3 minutes. Discussion of the council members before open individual voting of their defense results. For that period, sound shall be switched off if necessary. Open individual voting. The chairman shall count the votes and the results shall be recorded in the minutes of the meeting. Making decision on awarding or not awarding the degree, and closing remarks of the applicant. No more than 2 minutes. Dear colleagues, do you have any questions or objections to this procedure? No. I think there are no objections, so let me start. Let's start our session. First of all, let's switch off your mobile phones. Let me check mine. Thank you for your understanding, and let's start. Well, the thesis by Konopelko, Dmitry, Leonidovich for the degree of Doctor of Geological and Mineralogical Sciences, Scientific Specialty 250001, General and Regional Geology on the theme Paleozoic granitoid magmatism in the Western Tien Shan, was accepted for defense by the order of the Academic Secretary of St. Petersburg University of the 14th October 2020, number 9211/1. Konopelko Dmitry Leonidovich wrote his thesis at St. Petersburg University. His academic advisor, the Doctor of Geological and Mineralogical Sciences, Professor of the Sedimentary Geology Department of St. Petersburg University, Bisker Georgy Sergeyevich. The number of publications of the applicant which set forth the main scientific results of the thesis according to the enclosed list is 27, including publications indexed in the scientometric databases Web of Science and Scopus, 26 publications. The degree applicant submitted to the academic secretary of the university a full set of documents for acceptance of his thesis for consideration and defense. All the documents comply with Article 12 of Section 3 of the Order. All the documents submitted by the applicant, according to information I received from the curator, comply with the requirements and are kept in the applicant's attestation file. Copies are available from the officer of the Dissertation Council Activity Support Department, who is currently present at our session. Before I give the floor to the degree applicant, do you, dear council members, have any general questions to the applicant, and is it necessary to review the entire list of submitted documents? There are no questions. Dmitry, Leonidovich, the floor is yours. Thank you. Thank you. Dear Chairman, dear council members, dear colleagues, let me introduce my work, the Paleozoic granitoid magmatism of Western Tien Shan. The Oceanian belt formed in the end of the Carbonic period, the closure of Turkestan Ocean and collision of Tarim and the Karakum with Paleo Kazakhstan. Despite some fundamental descriptive studies before modern geological methods were applied, many problems remain unresolved. In particular, the nature of magmatism at the southern massive margins, the duration of magmatism episodes in the northern margin, the time of opening of the Turkestan Ocean, and many others were not clear. The present work has been carried out to solve these problems. The aim of the work can be formulated as follows: the study of the evolution of granitoid magmatism at convergent plate boundaries during transition of subduction environment to continental collision environment, using the example of Western Tien Shan. This slide, the upper diagram, shows the Hercynian belt of southern Tien Shan in brown, and the lower geological map shows the studied areas from the Aral Sea area to Victory Peak on the Kyrgyz-Chinese border. The tectonic diagram, I beg your pardon, we have to call a technical break. 1 minute. 1 minute, please. The technical break is over. Dmitry, Leonidovich, please continue. The tectonic diagram shows that the work areas are located both within the South Tien Shan terrain, which is considered to be mainly the former passive margin of the Turkestan Ocean, and within the Middle Tien Shan, which was the northern active margin of the Turkestan Ocean. Both of these terrains have been studied within Uzbekistan of Chitkalakramin block of the Middle Tien Shan. Here, all the age levels of granitoids are most fully represented. Here, super-subduction granitoids of silver devon, super-subduction granitoids of carbon, post-collision granitoids of early Permian are established. The examples of these intrusions are shown in this slide. These include typical granitoids, Indian-type batholites, such as Kurmazar batholite, amphiol granites with mothic inclusions, as well as post-collision intrusions of Shoshenite series, and numerous volcanic rock suites such as Kurmantau Formation, which the big Kinnaman deposit is associated. These supersubduction granitoids have characteristics typical of the magmatic series of Andean-type active margins and fall within the fields of volcanic arcs in the discriminatory diagrams. Post-collisional granitoids belong to the Shoshinite series. These are shown here in purple. They have geochemical features of supersubduction series but enriched with incompatible elements. In southern Gisar, the picture supersubduction granitoids and other permanent post of the Gisar and early permanent subduction. The geochemical features are yet sultanovise, supersubduction, Devon, and early permanent post-collision granitoids have been established. But, however, unlike in other areas, the granitoids of sultanovise are characterized by poor primitive geochemistry and isotope composition. Of the southern axis have been studied in the vast Kizilkum Desert and Nurata Mountains. In these areas, the supersubduction granitoids are absent, but post-collision granitoids, on the contrary, are characterized by extreme diversity of composition. Examples shown in this slide include for Timur Kabuk Massif, which is amphibole granites with morphic inclusions, and Kashrabat Massif, which is very close to A-type Rapakavi structure. Also in Kizilkum, all the aphelites by stratified gabbro. Kizilkum segment belong to the alkaline calciferous series, but several intrusions include calcifer from the composition, the Kazalkum, A granites and rare S granites. Thus, the duration of the first Silurian-Devonian episode is established by 12 samples, 414-409 million years. The second episode of subduction, 19 dated granite samples, 289-320 million years approximately, and the early Permian post-collision, for example samples of Kizilkum-Narata region fall within the period 293-285 million years. The next area we studied in the Alai segment, the so-called Alai segment, also see the geological diagram, which shows the specific structure pattern. Such distribution is characteristic of post-collision inclusions. The Alai segment distinguished by I-type granitoids, Shoshinite granitoids, shown in purple here, the high alumina granitoids close to S-type, and alkaline rocks and carbonatites. These are alkaline rocks studied by St. Petersburg University, including Nikolai Shinkarov and others. 6 dated granitoids fit into a narrow interval of 275-287 million years. Again, early Permian post-collision stage. And finally, the easternmost studied area is located in the Koshkal range and corresponds to the Kokshal segment of southern Tien Shan. More than 22 intrusions have been studied here, which are composed of relatively homogeneous granites, which are divided into 2 subcomplexes: large intrusions and small intrusion stocks of highly differentiated lava-bearing leucogranites, shown in red here. The example of rocks of large massives include typical Rapakavi, petrolite Rapakavi, morphic rocks, bimodal series, and in this photo it's clearly visible that there are signs of simultaneous intrusion of acid melts. Small intrusions located in eastern part form an interesting association with large intrusions of calcareous alkaline series embedded along the southern tension suture, and in this picture shows the on Inelchek River, the Victory Peak in the background, to the Trexine Massif, gneiss-like granites. A couple of kilometers away is a stock of undeformed lava-bearing granites and a deposit. Examples of rocks of these intrusions are shown here. Typical gneiss-like granites, both are dated, the age is the same, and examples of rocks of small intrusions made of lava-bearing leucogranites. From the point of geochemistry, Kochal granites are high iron granites, fall into the field of A-type granites on the classification and discrimination diagrams, and the rocks of calcareous alkaline series differ greatly both in geochemistry and distribution of rare and rare earth elements in comparison with A-type granites. The same can be seen in distribution of rare and rare earth elements and discriminative diagrams where the alkaline series fall in the field of volcanic arcs and the A-type granites fall in the field of intraplate granites. They also differ in tin content. Thus, granitides of Kochal segment are classified as A-type granites. The age of 8 dated intrusions is 279-296 million years post-collision stage, and the tectine and Ulan massifs of the South Tien Shan suture composed of different granitoid of calcareous alkaline series correspond with the age of A-type granites. Thus, for the entire region, formation of post-collision intrusions is a result of a single magmatic episode in all terrains, regardless, was established in a narrow time interval of 270 to 195 million years. In general, for the region, we established that the ages of phyalites indicate the opening of the Turkestan Ocean, not the Cambrian Ordovician. Episode of magmatism is Silurian early Devonian period, resumption magmatism in the middle of Carbon period, and established early Perm swept the region after the closure of the Turkestan Ocean, the late Carbon period. The first assumption summarizes the new geological data of 4 stages of granitoid magmatism associated with the evolution of the Turkestan Ocean. First, the plagio-granites of phyalites, 438-506 million years old, super-subduction granitides in the time interval 414, 409, and 320 million years old, and post-collision granitides 280-295 million years old. Thus, in Western Tien Shan, we identified 2 groups of Paleozoic granitoids, Devon super subductional and early permanent post-collisional. Post-collisional ones are common in all terrains, while super subduction ones are local in Sultanvice, Chatkalkurama, and Hisar. In the Kizilkum, Ala, and Kochal segments, the post-collision intrusions were introduced after a long period of amagmatic development. The age distribution is illustrated by these histograms, and the second protected assumption describes the distribution of the granitoid series of various composition in different terrains. The magmatic series of active margins common to Chatkala-Kuram, Hisar, and Sultanvice are represented by supersubduction granitides of the calcareous alkaline series post-collisional Shoshinite granitides. Their nature, the post-collision magmatism of the passive margins, is determined by the structure of the foundation. In the Kochal, built on the Precambrian foundation, A-type granites predominate. For Ala and Kizilko, where the foundation is more heterogeneous, associations of granites I, S, and A types is characteristic. The dating of crystallization ages by zircons in combination with the determination of isotopic composition, origin of magma. The negative value of epsilon indicates their origin from crustal sources. All granitons of Alai are all characterized by negative values, epsilon, niobium, and mesoproterozoic of niobium and hafnium, which also indicates their origin from the mesoproterozoic or older crustal sources. Most of the granitides in the territory of Uzbekistan are characterized by crust or mixed isotopic compositions of neodymium, strontium, hafnium, which also indicates a predominantly crustal origin. The exceptions are granitos of Sultanovais and the rocks of the north of Kizilkum, where the mantle value of epsilon. Thus, granitos of Kshar are characterized by crust isotopic compositions. Granitos of Chitkal and Hisar are characterized by crust or mixed composition. Granitos of Kizilkum Nurata by mixed isotopic composition. However, some granitos in the north of Kizilkum desert and all analyzed granitos Sultanovais characterized by primitive isotopic and rare earth composition. Thus, the third protected assumption is formulated as follows. The source of granitoids of most of the terrains of the western Tien Shan were Neo-Proterozoic or older continental crust. Granitoids, the source of which was the island arc crust, were found in Sultanovais and northern Kizilkum. Let us mention such juvenile blocks found in Tien Shan for the first time. Identification of a narrow time interval and of post-collision granitoids, diversity of composition of required development of a model. Chetkala Kurominsky block, Devonian and Kabardis was an active margin in Pale, Kazakhstan. The post-collision complexes represented by Shoshanite series. Shoshanite melts derived from VH enriched in subduction episodes. Heating and melting of this enriched wedge as a resulted from slab separation at the post-collision stage. The in Kokshal and North fault zone resulted from simultaneous melting of translithospheric sifts at post-collision stage. The model of this intrusion is shown in this slide. Major shifts that occurred post-collision stretching environment lead to the rise of hot matter and transfer of heat to the low and middle horizons of the crust. The Alai microcontinent after collision was squeezed between two latitudinal sutures, which led to the elimination of its lithospheric mantle and formation of contrasting series of granitoids. As a result of the rise of hot matter from the noospheric mantle and its interaction with various crustal protoliths. The same model is applicable to Kizilkum segment. Thus, the fourth and the last assumption is formulated as follows. Post-collision granitoids formed in different geochemical environments. The formation of Shoshanite series of Chitala Kurama associated with separation of the slab, formation of intrusions of the Nuta Martian Kokshal associated with the rise of matter from the noosphere to the zones of regional shifts. The heterogeneous structure of the foundation of Kizilkum and Alai contributed to the delimitation of the lower crust and replacement of its materials from the noosphere. Thank you. Thank you, Dmitry Leonidovich. Now, we have the time for questions. What questions do we have to the speaker? I have a question, Dmitry Leonidovich. You identified two groups of granitoids, subduction and post-collision granitoids, but you never mentioned granitoids formed in the collision environment. Are they absolutely absent, or you put them in together with the post-collision granitoids? Hello, can you hear me? Thank you. Indeed, this division is conventional, of course, to some degree, but the truth is that collision granitoids traditionally not established in Tien Shan because it doesn't have appropriate granitoid types. All authors mention that it was special soft collision, and it doesn't have major areas of metamorphines, of crustal melting, no granites of S-type. You can count them with one hand fingers, and considering this, it's convenient to group into post-collision series which have all the properties of post-collision typical I granites, I-type granites, and other structures, all things typical in active margins of the Andean type, and post-collision non-deformed. That is, so this is my answer. Thank you. More questions, please. May I ask a question? Buslav Mikhail from Novosibirsk. First of all, thank you for your report. And Dmitry Leonidovich, I have the following question. I have 3 questions. Shall I give all the questions? Maybe one by one. Okay, my first question is about the in your report. In your report, you said that granitoids belong to various terrains or segments and frequently used the geographical identification Alai segment, Uzbekistan. Is this because the tectonic terminology for this region is not available yet, or is this because you have your own opinion, formation or subduction zones or division in subduction zones? Thank you. Indeed, different authors call these terrains or blocks differently, but the most common opinion is that southern Tien Shan, which is very vast from the Aral Sea, stretches to the border with China and into China, and since it is very vast, all over 2,000 kilometers, it's convenient, and traditionally it is divided into Kızılkum-Nurata segment because southern Tien Shan is an arc, Alai Hisar segment, and Kokshal segment. So this division is rather traditional, and you come across these names. These names are used by many authors, so I abbreviated the names to save time. The second question is connected with the category identified as post-collision granitoids, the early Permian, the 280 and 290 million years old. My question is, by age, this event coincides with manifestation of such plume machine as Tarim plume. Recently, in Novosibirsk, a thesis was defended, and most magma complexes of this age are located in eastern Kazakhstan, which is quite near, were associated with the results of manifestation of these plumes. Granitoids formed as a result under the impact of Tarim plume. How will you explain that? You have a different approach. Novosibirsk school prefers the appearance of magmatic complexes with Tarim plume. I understand your question. Thank you. The Tarim plume maybe indeed existed. This is a geological fact, maybe. If it stretched all the way to Kazakhstan is a question. As for the impact of Tarim plume on formation of granitoids of Tien Shan, this is a very natural question, and there are many publications which discuss collision associated with the plume. So we do not we have no objections to Tarim plume, but in our work we have not discussed it because we focused. A plume is like a mechanism of carrying heat to the crust, but what mechanisms became active in the crust This is what we wanted to discuss in my thesis. So the mentioning plume is not, and I'm not against this impact, but I focus on the mechanisms in the crust foundation, which led to melting, so these mechanisms we explain as the way we explain them. Thank you. I have one additional question. Basaltoids of this age in this area, have you found any? Yes, we have. Not they are quite rare in 2 or 3 cases with A-type granites of Kakshal, such as Rapakivi, Kamogrosmorphic rocks I showed in photos, and gabbro intrusions in Kızılkum as single events, isolated events. So what's the how would you characterize them of basaltoids? As for morphic rocks, granites, granitoid massives of Kakshal, these are typical what gabbro Rapakivi granite formation, serious high iron content. So it's hard to relate them to plume directly. There are of course such connection. These are dry melts, high iron type ferrodiorites and similar rocks. As for morphic intrusions of Kızılkum, they are poorly studied, but in my opinion they should be related not with the plume but with the ultramorphic Permian complexes described in the shift areas in Chinese Tien Shan. There are some intrusions of Alaskan type, ultramorphic, in the shift zones, shift areas, both in Alai and Tien Shan, and I think these are similar to those formations. Beg your pardon, and I have hopefully maybe my last question. That's because for myself I would like to clarify some points. The geometry, I'm talking about slabs, slab detachment in cross section is very easy to detach a slab crust and move it, but as for protrusion, in your opinion, how long should this fracture or detachment line should be to explain some responses from the mantle because of the slab detachment? In cross sections they look ideal, but what about the area, the surface area? How extensive this detachment should be? It's quite difficult to answer this question because in Hercynians we are dealing only with fragments included in later tectonic history, and fortunately in this Chetkala-Kurama region perfectly preserved fragment of a typical Andean margin, and we see all the features that indicate that post-collision what occurred at post-collision stage slab detachment or slab window. A fragment that in the east maybe was destroyed by tectonic erosion, and the western fragment got overlapped, covered maybe, and Sultan of Ice maybe it can be seen. Additional question, please. I can understand what slab detachment is if the subduction zone goes in the middle of ridge, submerged part, followed by opening, and then a slab may be detached. But how would you explain the mechanism of slab detachment when lithosphere is broken itself? I have no problem there, because in that part of Tien Shan many Devonian sea mountains have been identified, described together with scientists from Novosibirsk, and these sea mounts quite numerous, quite large, so they could play a role of indenter that provoked slab detachment. I beg your pardon. With that, I cannot agree. Okay, thank you. More questions, please. Dmitry Leonidovich, I have two small questions. All your dates are based on zircons. And what's the time of crystallization of zircons in these rocks in relation to other minerals? And is it possible to date zircons and then date other minerals crystallized much earlier, much later than your zircon? Thank you. In addition to zircon datings, we argon datings and many low temperature chronological studies, and we conducted, and we have enough material in isolated granite massif. We may see zircons which coincide with crystallization of these granite massives, and which are 20 or 30 million years older, and then captured by magma later, got captured by, and argon ages also enable us to decipher and to see the history of granite massifs, and they are quite similar, so they do not disrupt the overall picture. In your slides, we could see that granitoids contain various intrusions, morphic intrusions, so maybe we may suggest that granitoids contains lots of small crystals. The isotopic data obtained on strontium, lead, how can you guarantee that you don't have contamination, that all your data reflect granitoid material? Of course, you may say that the substance was heterogeneous, but what's the degree of heterogeneity of these granitoid massifs within each intrusion phase? I see. This depends on what material you analyze. If we analyze zircons, the age and isotopic composition of hafnium in zircons, of course, in most granite massifs, we identified xenogenic, heuristic zircons. In some cases, they were analyzed and discussed separately, and we were not taken into consideration when analyzing the medium with epsilon hafnium. But as for general issues with containing rock, when considering niobium or strontium isotopic compositions, we also took this into account. We considered this, but usually we conducted 2, 3, 4 analyses, and if they look the same, we assumed that such hybridization maybe occurs at deeper levels, and magma was got homogenic. Thank you. More questions, please? Two small questions. In one of the graphs, you show lift of noospheric matter, and judging by your graph, this hit looked like so the properties are not should not be depicted like that. And in the third defended assumption, you said that the nature of magmatism depends on the other factors. What are the other factors? As for the charts of those channels up which the matter rose to sub-horizontal detachment zones and how big they can be, of course, this is an exaggeration. You shouldn't take it literally. As for the sources of matter, of course, we can assume mantle sources or mixture of mantle and crust components. In some cases, we can see such mixture. For example, in super-subduction series, and such mixed isotopic compositions are characteristic for active margins of Andean type, where a mix of crust and mantle melts is characteristic. No, that's not what I mean. I mean that not only the composition or nature of magmatism is determined by the degree of melting, crystallization, differentiation, presence of fluids, etc. So that's what I mean. Of course, at that level, at such level, we can see such processes, for example, in Kokshal, where in large massifs of western part there are no or few highly differentiated melts, and in the eastern part there are we observe small intrusions of lava bearing leucogranites, and obviously the same fracturing line of these portions. Thank you. Dmitry Leonidovich, in your last work published this January, you address some processes. You describe how these data agrees with your provisions, your assumptions, protected assumptions. Thank you. In this paper, I describe minerals not in southern Hercynian Tien Shan, but found in northern Tien Shan, connected with a Caledonian island arc about 500 million years old. So to closure of Turkestan, the evolution and closure of Turkestan ocean, they are not connected, but they are related with the evolution of an older, of more ancient branch, Terskayan Ocean. Thank you. Well, I have two small questions. Dmitry Leonidovich, as I understand, heat is controlled by major fractures or shifts. Is that, or am I wrong? This is one of the possible mechanisms of lift from nospheric hot matter that takes heat to the crust, to the core. Can you show on the modern map there are many intrusions associated with the shift zones? They're quite well known and quite well studied. For example, Armorica granites in French among Hercynians of the same age, or massifs in Central Massif in France or on Bohemia. They are very numerous, well described, well known, and all researchers agree that this melting is connected, that the shift zone is a convenient magma channel, and there has to be some mechanism to carry heat, for carrying heat. Have you found any remains of such fractures? Any remains of such shifts? Any traces of such shifts? Thalassa Fergana fracture fault. Along this fault, there are some intrusions. When Thalassa Fergana fault was active, we have dated them 280 million years, or South Tien Shan suture, which I mentioned, and in China, which continues to China. Well, dear colleagues, if we have no more questions, let us move on. Пожалуйста.
Can I ask a question?
Да, можно мне задать вопрос?
Oh, of course, for now in English. In your thesis, you
В своей
described,
диссертации вы описали
and your talk today, you described
и
a strike
сегодня
slip system
говорили
along the former suture zone.
в бывшей
The Alai and Tarim blocks, or the Kokshal and Alai segments,
Кокшале и Алай
you've suggested have
сегментах
different styles of basement
имеют
based on your isotopic data.
различные основания,
Today,
фундаменты
the boundary
на
between
основе изотопных данных.
the Kokshal segment and the Alai
Сегодня
segment
граница между
is
кокшальским и
the
алайским
Thalassa Fergana
сегментами.
fault. I'm wondering if you see any variations in
Видите
the
ли
type
вы
of magmatism or
какие-то различия
metamorphism
между магматизмом,
in the Alai and Kokshal segments,
между алайским и кокшальским
which
сегментами,
might correspond to
которые
the different
соответствуют
types of basement,
различными типами
and therefore whether it's possible,
и
because the
которые
different kinds of basement might have had
позволяют
somewhat different kinds
таким
of
образом, поскольку
collision,
существуют
if you can constrain the amount of strike-slip faulting which occurred
столкновения,
across parallel to the length of the Tien Shan
происходили вдоль
prior to being offset by the Thalassa Fergana fault.
Тien Шане. Спасибо. Действительно, характер магматизма таримской окраины Тянь-Шаня в алайском сегменте очень отличается. В Алае мы имеем дело с контрастными сериями, шанитовой породой, похожие на граниты S-типа.
Excuse me, I'm only hearing the Russian, not an English translation of your answer. I do not hear anything right now.
Он слышит перевод, а я сейчас говорю по-русски. Он же по-английски говорит. То есть должен переключиться этот выступающий, чтобы слышать напрямую докладчика.
Если выступающий идет по-английски, он же не это самое. Если вы выключите микрофон...
Так я по-русски говорю. Я не выключу. Ну, я...
Until now, the translation was perfect.
All right. Хорошо, да, прошу прощения. Я начал отвечать на английском, но оказывается...
I beg your pardon. Unfortunately, you can only hear the translator, so it's impossible to. You cannot hear the speakers speaking in English. So unfortunately, you'll have to listen to me. Sorry about that.
That's perfect. I'm happy to listen to you. Your English is great.
Thank you, sir.
Now I hear you clearly.
Indeed, the alai magmatism is very different from Kokshal magmatism. For example, alai manifests typical I granites, Shoshanite series as granites, and Harma blocks, metamorphic block. And it would be great if we could link the I granites of alai, such as Karakshin batholite, with subduction zone, but all ages correspond to the post-collision stage and fall within a very narrow time interval. It's hard to explain that. But one possibility to explain this is to choose various protholiths, melting protholiths. And the second way to explain this is the presence of subduction zone in the south. So maybe the carbon subduction zone, the material on which you have published recently, together with your colleague, and the manifestations that is second way, the evidence, the second explanation is correct, is the presence of zircons, 320 million years old, in granitoids of the alai segment. In granitoids of alai segment contain xenogenic, captured or recycled zircons, which are 320 million years old, which may indicate that in the south there was a subduction zone, and I granites and Shoshanite granites are connected with this. This is the answer to why different granites in Kokshal and alai are different. As for the range of shift and the nature of the foundation of alai microcontinent, how similar or different it is from Tarim, it's hard for me to answer. Because according to the data of xenogenic zircons, the foundation of alai microcontinent is near Proterozoic age, approximately 600 or 800 million years, which is different from Tarim. Here is my answer. This is my answer.
When do you think that the alai microcontinent
Когда
became separate
алайский
from
микроконтинент
Tarim,
отделился от
or when did it
Тарима,
come back together with Tarim,
или
if
когда
it
он,
has
наоборот,
a younger basement?
соединился, если у них один фундамент?
Or to rephrase the question, why is it a microcontinent? Why is alai a microcontinent?
И почему вы называете Алай микроконтинентом? Это этот вопрос является частью очень обширного, the part of a broader question, which relates to the continental foundation found further in the west, the so-called Karakum continent, and other microcontinents in its vicinity. And as our present knowledge suggests, the foundation of alai is more similar to the foundation of the Karakum continent, studied in Uzbekistan, Tajikistan, and South Kızılkum region. And since all the data about the Karakum continent point at late Neoproterozoic age of this either karst ages, approximately 580, 630 million years. In Karakum, we don't see the ancient nucleus, which we could associate with Karakum and Tarim.
Thank you.
Спасибо. More questions? If I may ask one more question, says, could you please tell me, Dmitry Leonidovich, you said the manifestation of granitoid magmatism is associated with subduction of Turkestan Ocean in the region. You see, pre-Cambrian microcontinents, were they part of the Turkestan continent, ocean? And if yes, then if granitoids contain zircons or some serious isotopic markers that evidence this. Thank you. This is a very interesting question because, yes, of course, there are such markers and they give us the reasons to describe the nature of the foundation. Protolith of granitoids, the only protoliths that do not contain xenogenic granites. These are A-type granites of Kakshal because these are hot magmas, and Rapakvi granites usually never contain xenogenic zircons. So the issue of protolith from which Kakshal granites were they melted from Tarim foundation or were they melted from the cover, from the coat? Is connected. This issue is being discussed in relation with tin deposits, but in all types of granitoids there contain a lot of xenogenic zircons of different ages. Majority of Proterozoic age, so Neoproterozoic foundation is quite spread. There are archaic and lower Proterozoic, archaic, and in some parts of Kızılkum, especially near Kurumtau deposit, the proportion of such zircons is very high, up to a half of all xenogenic grain intrusions or even higher. And this leads us to some interesting idea about the structure of the foundation and how it is connected with the formation of Kurumtau deposit. And about zircons, may you say that these zircons pass through a subduction zone or they are come from the foundation? They got into the magma complex from the foundation. We don't see any direct evidence that the zircons passed through a subduction zone. First, we see recycling in the active margin, continental arc, magmatic arc, zircons. We see Devonian zircons, magmatic zircons in carbonic supersubduction granites, and we observe foundation zircons, which is typical from the foundation, which is typical for this area. Of course, it is possible that zircons went through a subduction zone, but we don't see any reasons to assume and prove and argue that. Well, colleagues, I think we have asked enough questions. We have tortured Dmitry Leonidovich enough. And Mikhail Mikhailovich is smiling. If there are no questions, then we can proceed to the next point. The next item is reviews or speeches, reviews an assessment of the thesis and the applicant's report presentation. External reviews, as far as I know, we have not received any. And all the reviews have been published at St. Petersburg University website. So I suggest that we focus on the key points only, comments and questions in reviews, and maybe Leonidovich will take all the questions in the end. So any objections or any comments at this point? Then let's hear the reviews. Arzamatsev Andrei Alexandrovich will start. Dear colleagues, first of all, I'd like to say that, of course, this work certainly stands out for its relevance, complexity, and in my review I mentioned all that, and I explained why I think, and the Paleozoic magmatic series of Western Tien Shan have been studied with a wide range of modern methods by the author, which including local dating, isotopic composition of niobium, hafnium, lead, which explains scientific novelty of the thesis. So I will not dwell, and I will not read my entire review. I will not dwell on this. I'll go straight to critical remarks. So first, it seems to me that a great age difference of plagiar granites of the first stage is not justified enough. It appears to be that more likely 70 million year interval divided into contains several short pulses of magmatic activity. Second comment, it is advisable to give better explanation about slab detachment and delamination of lower crust and replacement of noosphere material. We already heard some comments on that. So I think I will be satisfied with what I heard. And comment 3, since the author subcollision granitoids separately, would be advisable to provide a map where we could see such regional distribution of such granitoids. So these are my critical remarks, but in general, of course, the work of Dmitry Leonidovich corresponds to the main requirements set by the order of the university, and the applicant, Dmitry Leonidovich Konopelko, deserves being awarded the degree of Doctor of Geological and Mineralogical Sciences, Scientific Specialty 250001, General and Regional Geology. Thank you. Thank you. Next, Edward, your review, please.
So I was quite impressed by
На меня
the
произвела
breadth of the
большое
material.
впечатление объем
It's
материала.
a huge amount
Это
of
огромный объем.
studying over what I know to be a very broad and sometimes challenging to access origin. In general, I thought the work was quite good. Like the others, I will not comment on the parts that I thought was good, which of course is hard to listen to. But instead, I will just ask a question or two that I brought up in my review. The model proposed for the post-collisional magmatism is that this is rising up along weak pathways caused by a post-collisional origin parallel strike slip system. During subduction, presumably there was a down to the north slab, which must have broken off. And the model suggests that similar to the San Andreas fault, there's a subvertical structure which brings up heat. And so my question would be how you transform geodynamically a system which is dominantly origin convergent to origin parallel motion, and how you transform something that should have been a fairly low angle system to a very high angle system in order to bring up the heat. And it would also have been interesting to have seen, there were some nice origin perpendicular cross sections proposed, and I think it would be really interesting, although challenging and speculative, to try making map scale reconstructions to see how the system propagates along strike and changes character along strike, although I know that that would be even more speculative than the cross sections. I concur with the previous review that this work is indeed more than acceptable as the basis for receiving the degree. Thank you.
Thank you. Anatoly Nikolaevich, now it's your turn. I shall drop the complementary part, or I shall summarize it in 3 sentences. The work evokes great respect for the author, Dmitry Leonidovich. We've known each other for a long time. We have never worked together, and maybe it's a shame. It would be interesting to work together, but it seems this work is in high demand. The articles, the information published by the author are in high demand. So I'd like to congratulate Dmitry Leonidovich, and I would like to congratulate his scientific advisor. Honestly, what I did not like in this thesis is the mineralogical part. I explained why I didn't like it. Maybe shouldn't Kalishpat, amphibole, you know what filled spot, what mica, what amphibole, there is no such word, there's no such term, there's no such mineral. It's a mixture of minerals. So these mineralogical insignificant details, but when you come across, they really jump into your eyes. But from the experience of reviewing articles, spectrology or geochemistry, you come across these things in many articles. So maybe we should do something about this. And of course, the thesis by Dmitry Leonidovich, Konopelko, on Paleozoic granitoid magmatism of Western Tien Shan corresponds to the requirements set by the order on awarding academic degrees at St. Petersburg University, and the degree applicant, Dmitry Leonidovich Konopelko, definitely deserves being awarded the degree of Doctor of Geological Mineralogical Sciences, Scientific Specialty 25001, General and Regional Geology. Article 11 of the above-mentioned order has not been violated. Thank you. Thank you. Mikhailovich, now it's your turn. Thank you. I would like to mention such qualities of the applicant that I know from his works and from his thesis as geological mapping. He's making maps, geochronological and geochemical isotopic research methods. And I know that apart from granitoids, he has studied. He has some good works on high baric associations, and if so, he would also do a thesis on such type of rocks. As for the thesis itself, the title or the purposes, assumptions, it's nearly ideal. The questions that I have asked, dynamic aspect, and I know that there is no universal or perfect answer to these questions, and Dmitry Leonidovich, with his answers, in my opinion, I was satisfied. Some questions we need further discussion, which hopefully we will be able to discuss in the future. But in general, I would like to thank Georgy Sergeyevich, the scientific advisor, and the university colleagues. With your support, such an expert was trained who, without any doubt, deserves the desired degree, Doctor of Geological and Mineralogical Sciences, specialty general and regional geology. Thank you for inviting me to participate in this remarkable event. Thank you. Thank you, Mikhailovich. So maybe we will next time I will come visit you next time. Ivan Konstantinovich. My review is positive. I will not. The part that I liked most, the thesis, the combination of data of regional geology, tectonics, and the abundance of isotopic and isotopic chemical data. This takes the thesis to a much higher level compared with previous years, makes it much more justified. Here, I would like maybe to mention only one thing. I have not mentioned it in my review. In one of the last works of Kruner, many conclusions are made to date on the basis of geochemical isotopic data for development of processes of formation of the continental crust. And here should be careful about what do we mean by isotopic or geochemical composition, because in many objects the mixing processes in when melting have been identified. So this line in the future, this field will develop in the future, and considering the statistical data, correlation of geological processes and of granite formation, we may consider them well justified. Among the critical remarks, I'd like to say it's a little unusual to date granitides by with the ablation method. It's very approximate. The classical method is more reliable, and considering the amount and the coincidence, the statistics provided by the author, the assumptions appear justified. And last thing I'd like to mention is that this combination of geochemical petrological methods and regional geology increases the value of this work, and the author certainly deserves awarding the degree of Doctor of Geological and Mineralogical Sciences. Thank you, Ivan Konstantinovich. Dear colleagues, with your permission, I will not read my entire review. I certainly think the work the author certainly deserves being awarded the degree. I have been following works of our applicant. And we have discussed them a lot. I've never came across a single thesis which evoked no questions, because it's impossible to resolve everything. Of course, I have some critical remarks which are quite minor. So, and one suggestion I have to the author for his future studies, first of all, to take geochronological data more seriously. Now we have the impression that they can be obtained easily and justified, but the geochronological data should be evaluated. Every researcher should do this, because there are geochronological data, and let me say again that the work certainly meets all the criteria applied to thesis for the degree of candidate of geological and mineralogical sciences. Thank you. Thank you very much. And Andrei Mikhailovich, for many years or decades, I have been watching the evolution of Dmitry Leonidovich's work since his early works on the Baltic platform, and with great interest. I have always enjoyed reading his works, his articles, and this paper as the essence of his work. I think this is a tremendous work on geology of the Central Asian folded belt. The work certainly deserves awarding the degree. The work is interesting, contains lots of essential material. Is scientific and practical value of this work is obvious, and here I'd like to emphasize that, first of all, this practical values can become the foundation for geological maps and for further research in this studies in this region. I don't have any major critical remarks. So first of all, maybe the geodynamical models are too hypothetical, maybe. So try proving those, and maybe would make sense to focus on processes of formation of Shoshenite series. For post-collision magmatism, these Shoshenite series rocks interesting from the point of its genesis, and usually a wide range of interesting deposits is associated with them. But in general, of course, the work certainly deserves awarding the degree, the doctoral degree. Well, I have to say that I took certain part in Dmitry Leonidovich's work at St. Petersburg University, and I'm very glad he's here with us now. And Dmitry Leonidovich's decision to write a thesis, I have no doubt that this work is a high quality thesis. Any work of such level, of such significance, provokes questions. Some questions I include in my review: how heterogeneous structure of the foundation resulted to delamination of the mantle. I didn't like some of the language. It's quite similar to Anatoly Nikolaevich's comments. Post-collision granitoids formed in various circumstances, in various environments. Post-collision environment is not a geodynamical situation, so maybe the language is wrong. Same is true about Sarandra's fault. There's no doubt the interpretation is beyond any doubt, but maybe I think we may hardly say that this is a typical post-collision shift, because this is not a post-collision structure. And it would be interesting for me to get more comments on geodynamical evolution, especially where the transition, if I understood him correctly, the scheme from the active margin to passive margin, because the transition to passive margin, but the reverse process is not as obvious. Also, I'd like to emphasize at the same time that these critical remarks are only points for discussion, and by no means they do not affect the overall impression of the work, which I have no doubt in the level of the thesis. Of course, the work corresponds to meets all the requirements. Thank you. Dmitry Leonidovich, we finished we presented all our reviews and asked all our questions. I would like to thank council members for your questions and remarks, and some questions relate to the use of San Andreas fault structure to interpret the origin of Tien Shan post-collision complexes. First, it's noted that San Andreas fault is not a post-collision structure. Second, that San Andreas fault is a vertical active plate boundary, and the south tension structure was first deep northward Tarim, and next that it would be advisable to dwell on formation of post-collision stage. Let me answer these questions. First, San Andreas fault is really not a post-collisional structure, but we believe that the mechanism of uplift, meta-lift proposed by San Andreas fault could have worked in the translithospheric shift of the post-collisional stage in Tien Shan. Probably this should have been more clearly stated in the paper. Second, indeed, the South Tien Shan suture at first was a northward deep in thrust of the Tarim under the middle Tien Shan, but the geological facts show that already 280 million years South Tien Shan suture was already transformed into a regional left-handed fault and was developing in the same mold as with other similar, including Tarasa-Fergana fault and other regional shifts. As for the mechanism of this transformation, of course, this is a very interesting question, but it is beyond the scope of our work. It requires a separate structural study involving numerical simulation and other special methods. Two questions concern the delamination of the lower crust and its replacement by the aspheric material. This aligned Kizilkum contribute to the delamination. Heterogeneity foundation, first of all, explains diversity of post-collision granites, but the melting of granites requires thermal energy. The most probable mechanism of heat transfer was delamination of lower crust and its replacement with a hot metal. This is one of our defended assumptions. The heterogeneity of the foundation could have promoted delamination as the microplates of the foundation also moved relative to one another along the regional faults, which promoted the rise of the metal. Two questions were asked about the emergence of Shoshanite series as a result of slab detachment. Let me answer. It's generally accepted that Shoshanite series melted from the sublithospheric mantle enriched with incompatible elements during subduction, usually from the mantle wedge above the subduction zone. For this melting to occur in the post-collisional stage, a heat input is required, which can be provided by the emergence of the window in the slab or slab detachment in the post-collision stage. The paper argues that this model of slab detachment is the most probable for the Chatkal-Kuramin region. Two questions addressed the language of assumptions, a reasonably large age interval of formation of plagiogranites, and is more likely that manifestation of discrete impulses of this is absolutely true, but as the obtained ages are still the first and single plagio-ophalite for this vast region, and because it was necessary to formulate the assumptions briefly, the studied plagiogranites, we put them into the same age interval. We also, unfortunate language of assumption 4, the post-collision complexes formed in different geodynamic environments. This is also absolutely true. We should talk about different mechanisms, but again, due to the need to briefly formulate the protected assumptions, we use this language, this wording. Two questions were asked about geodynamic reconstruction, chapter 4. It was noted that it would be interesting to paleogeographic reconstructions, show them on a map. We have not done that but we are working on such reconstructions. We have not included them, but we plan to publish them in near future together with Georgi Sergeyevich Biske. It was also noted that the reconstruction for the 385 million years requires a clarification of the term passive mode of continental margin development, since the active margin cannot turn into passive one. Indeed, this is a magmatic period of development accompanied by the formation of carbonate platforms. The passive mode in this case is a descriptive term, and probably indeed was not very successfully applied. However, everywhere the term is used, we also explain that the southern margin, the middle Tien Shan, might have become transformed into a plate boundary. It was also noted it would be useful to provide a separate map to show the regional distribution of subduction post-collision granitoids. As the former active margins, the post-collisional series continue to form without any break, would be problematic to separate them on a single map. However, terrains corresponding to the former passive margins, such as southern Tien Shan, and former active margins, such as middle Tien Shan, margins clearly stand out in all the regional tectonic schemes given in the paper, thus illustrating the areas where subduction series are present or absent. Concern the remarks regarding the age of Madrum massifs and Uchkovsky massif. This assessment of zircons is useless. This is absolutely fair. But we had no technical opportunity to analyze most of the grains. But since the zircon population was very homogeneous, we were confident of these results and decided to publish them. Later, these massifs were redated by other researchers. Australian researchers redated these massifs by laser ablation, and the ages were fully and the age, our age, was fully confirmed, and they sent us an email with of respect. As the critical remark concerning the description of mineral composition, they are certainly fair. However, I'd like to point out that such simplified methods of mineral composition description are used as standard most non-mineralogical articles, and also that special methods such as micro-probe have been used, and the results reflected in the articles on which the thesis is based, but not included in the text of the thesis itself. Also, there's a number of technical comments and the suggestion to edit the English text. These comments are gratefully accepted. Thank you. That's all, Dmitry Leonidovich. Dear colleagues, council members, are you all satisfied with Dmitry Leonidovich's answers? We don't have any guests, so we don't expect any additional speeches. So let us give the floor to the scientific advisor, Sergei Sergeyevich. Welcome. As you all know, the School of Tien Shan studies at our university is almost 100 years old. And in the beginning, many scientists worked in this area, Shinkarev, Linsky, many colleagues worked in this field. So this situation continued until 1990s. And before that, together with Dmitry Leonidovich, we started working together. This was 30 years ago. In those days, he just started as a geochemist, his career, and so we joined our efforts, and even after the collapse, so we in 1990s we spent our own money, and of course now we have the necessary funds. And what assisted us is our attitude, our passion for the subject of our studies. Tien Shan is an amazing diversity. So it's impossible as a which can satisfy any geologist or paleontologist that would amaze. And this, our joint efforts yielded results. So we started to understand magmatism and collision magmatism. In particular, Dmitry Leonidovich feels quiet in geodynamic models, feels comfortable in the sphere of such models, and the history of geological development of this area, of this region. So that's how we are progressing. His candidate's thesis took a long time, and his doctoral thesis, he's not a young man anymore, but his thesis is an excellent thesis, and I absolutely agree with all the reviewers. And so what's next? Next, there's a lot to explore. There's still a lot to explore, a great number of questions to which we don't have answers. Some of the questions discussed here, applicability of some models of post-collision, Permian magmatism. This a huge flash of magmatism occurred. Detachment, it ends this collision events, end of Carboniferous period, beginning of a Permian, and so what you may think what you like of the collision event. So this post-collision magmatism, the models that Dmitry Leonidovich suggested, we have discussed. It's not that I don't agree with them, but I think that one model should prevail over the others, the energy model. So the heat is needed most of all. And here, the stearine plume came very instrumental. Our colleagues from Novosibirsk pay attention to that, notice that. And this is where here the plume manifested itself most. The same age basalt is a Rapakivi granite. Deposits are smaller in other places, such as I-type granites. West of Tien Shan, we have a different composition, same titles, but different composition of granitoids. So all these reasons do not exclude each other, but I think heating is the most important thing, and slab could or could not occur. But the shifting these faults, maybe they let heat lift all the way to the surface, but maybe the connection between the fault and the intrusions maybe is not that obvious. Only Dmitry Leonidovich mentioned only 2 spots where such evidence exists. So these are the challenges we are facing. So maybe I'm falling behind schedule because we am discussing questions we are going to discuss in the future. But thank you, Georgy Sergeyevich. I see we received no external questions. So, dear colleagues, would you like to ask more questions or discuss something? Do you have any additional questions? Would you like to add something? Dmitry Leonidovich, maybe you have any something you would like to add something? As I understand, according to the procedure, I will have the opportunity. Yes, that's so maybe not at this point. Well, we have the opportunity now, before we vote, to take a break to discuss the results of today's session, and the sound shall be switched off. Do we need such a technical break for discussion, or is everything clear? It seems we don't need such a break. Well, then we should proceed to open individual voting, and then I will count the votes. I put the question of awarding to Konopelko Dmitry Leonidovich the degree of Doctor of Geological and Mineralogical Sciences, Scientific Specialty 250001, General and Regional Geology, to open individual voting. Let me remind you that a decision council on awarding the degree shall be considered positive if more than a half, but not less than 3 members of the council present at the session have voted for it, according to Article 23 of the order. Let's start. Andrei Alexandrovich, your opinion? I'm for. I vote for. Thank you. Sobel, Edward, your opinion, please?
I vote yes, for.
Could you please repeat what you said?
I vote yes.
Повторите, пожалуйста.
Could you please say it once again?
I vote yes. I am in favor.
Anatoly Nikolaevich.
Anatoly Nikolaevich, I vote for. Mikhail Mikhailovich, I vote for. Ivan Konstantinovich, I vote for. Alexander Borisovich. I vote for. I fully agree. And Anatoly Mikhailovich, I am for. And me, I also vote for. I have no doubt. I have no doubt about compliance of this work. So the results of our voting: 8 council members voted for, nobody voted against, and nobody abstained. Thus, a decision to award to Konopelko Dmitry Leonidovich the degree of Doctor of Geological Mineralogical Sciences, Scientific Specialty 250001, or General Regional Geology, has been made. Thank you. Though, since our session, some participants work in the remote access mode. Does anyone have any further questions or remarks, comments? If not, let me, Dmitry Leonidovich, congratulate you on successful defense, and I would like to give the floor to you for your closing remarks. Thank you. Thank you. In conclusion, I would like to thank my academic advisor, Professor of Sedimentary Geology, Georgy Sergeyevich Bisker, for long works of working together in Tien Shan Mountains, his criticism and his friendship. I'd like to thank the head of the faculty who helped us to organize our field trips to Central Asia, and my colleagues for their support and their advice. I'd like to thank my colleagues and my friends, geologists in Central Asia, with whom I have been on field trips together, who helped me to organize these trips. I appreciate my colleagues from European institutes and worldwide, the Institute of Natural History Museum in London, for many years of cooperation, which enabled me to perform this work. I'd like to thank the chairman of this Dissertation Council and all the council members and the Dissertation Council Activity Support Department who organized all of this in these hard times. Thank you very much, everybody. Well, dear colleagues, I declare our session closed. I thank everybody for participation. Please stop online broadcasting.